it is already known that a Tesla coil creates longitudinal or dielectric electromagnetic waves, knowing of course that these electromagnetic waves are always transverse in the nature. In this Slayer exciter or catcher, which is always a self-oscillating resonant transformer, the reason that in the coil creates a current in not conducting in other coils, I mean the primary and the secondary coil, is because the principle of Lenz's law, which exists here. The secondary coil is drawing power from the primary while the voltage is changing and the current is always dropping from 0 to a 1. But this is not the point. I want to demonstrate you something else.
First of all, I would like to show you the circuit diagram of my Tesla coil I'm going to use in this experiment. I'm using an IRF 530 common MOSFET and some other components. It's nothing special, but it is good enough to show you what I mean.
Now I'm turning on the device. High voltage at the output. This is the output, 1 megahertz. But the most important thing is the ground. This is the ground. This is an inductor of 350 microhenry and the LED lamp, and as you see it's glowing. That means that it flows current inside the cable here. And this is what I'm trying to demonstrate you now. I interfere now a light bulb, a light filament bulb, between the end of the secondary coil L2 and the ground, right there. And see what is going to be happened. I'm turning on it. You see, the lamp lights up. And if, for any reason, if I disturb the resonance with my hand, let's say with my hand, the bulb lights up better. That means that we have electron moves between the ground. In this case, the LED lamp is no more in use. This is the setup I showed you before. At the ground of the Tesla coil is connecting this bulb of 10 watts from a microwave transformer directly to the ground. Also the ground goes through the lamp. And now I changed the setup. Instead of the lamp directly, I connected a variable coil of 14 tabs, altogether 140 turns, and then the ground. And the bulb, I'm going to connect it not between, at the very end of the coil. So from the Tesla coil and the ground. This is the coil, the tabs I showed you before. I connected the power supply. As you see, we have the current at the ground. Okay, the bulb. See, the same result at the very end of the coil. Now, if I choose another tab, right here for example, it is less. Lights up no more, just a little bit. So that means that using this coil I can variable the indux of the coil, and I can use it as a variable transformer of a high voltage. See it again, right here in the middle and at the end, just a little bit. Yeah. And of course, when the bulb lights up, the LED is shining also as it was before, just a little bit. Knowing that the energy flows through the ground from the Tesla coil, I changed the setup to this. First of all, I changed the coil, and instead of the coil, I have a rectifier consisting of 4 diodes, 4 fast diode UF5408, and a condenser of 6 microfarad at 450 volt. Right here, capacitor, the diodes, and power on. Oi. What I'm doing now is that the capacitor is being charged very rapidly from the Tesla coil and the ground. Tesla coil at the very end, the L2, and the ground. And right here is the energy. Thanks for watching.